Now let's look at how we can use the Python API to actually work with vectors. So you can see here at the top, I'm importing Maya.api OpenMaya, and remember we're using the API here so that we're using the new Python API. I'm also importing math just because we will need that a bit later on. So to create a vector, all we have to do is basically pass it in a list of 3 numbers of 3 floats, and it will return us a vector. So if I do that and I check this now, you can now see that we have basically an instance of an m vector, and it has exactly the values that we set here. So, that's just doing any of that, and we'll change that. So let's just change that back to what we had. Now, to actually reading these, instead of actually when we're using them in code, if you want to get any individual points of these, any of the individual components, you can do .x, y, and z, because that's basically what they will represent most of the time. So you can see if I just get all of this, it will return 0.0, 1.0, and 0.0, right? Because that's basically our vector, right? It's 0, 1, 0. So that's exactly what is printed out here. So that's just a bit of like a convenience function. You could also do by slicing it. So that will also return, the 0, 1, and 2 index of that. But using like x, y, and z is quite nice. We can also set the vector by the exact same way, where we can just say vector.x equals, and then just pass in a float. So if I modify the vector like this now, let's just double check what it is before, right? Before it's 0, 1, 0. We do that now. And after that, it's 0, 1, 0. Because that's basically what we've changed it to, modified it to now, right? So as we briefly looked at in the API overview video, we can very easily now use the mVector class to add multiple vectors together. So instead of having to do and going through and add each of the components together, we can now very simply say one vector plus another vector. So you can see here I'm creating a new vector of basically 1, 0, 1. I'm adding those two together, and then I'm just printing that out. So remember, our vector is 0, 0, 1, and our other vector is 1, 0, 0. So if we add them together, we basically get 1, 0, 1. Pretty much as expected. And there's nothing majorly different if we were to subtract the two either, right? So let's just refresh our memory here quickly on the vector is this, and if we subtract them, we end up with -1, because of course we have 1. 0 minus 1 is -1, and 1 minus 0 is 1 still, right? So working with the mVector class makes all of this super easy. And again, multiplying the vector, just to remember, that's basically what we have. And if we multiply it, we end up with 0, 0, 2, right? It goes through, it multiplies each of the components, and that's it. Now, this is where it gets really, really good for us, is all of those extra calculations that we looked at in how we can actually find the vector length. We don't really have to do that anymore. It's already built into the vector class. So to get the length, well, all we have to do is just say our vector.length, and it will return us the length of the vector, right? So if I instead took this multiplied vector, remember that we multiplied by 2, now this returns 2, because we scaled the original vector that had a length of 1, we scaled that by 2, so now the length of this one is 2. So very nice and simple there. And also it has a built-in function to give us the normalized vector. So for this, it's going to be exactly the same, right? But if we go back and we take this multiplied vector and we pass that in instead, you can see we're actually getting the exact same thing now, because basically our original vector that we had was pretty much normalized. It still had a length of 1. So this is super, super useful, and it's just really nice to have these convenience functions. Now, to do the dot product, we basically use a star. And you can see, as expected, it's returning back a float. Because as we looked into, the dot product is basically a scalar value. Now, why is this returning 0? Well, because if we look at these two vectors, they're basically perfectly straight, right? We've got the first vector going down in the z-axis, and then we got the other vector going down in the y-axis, in the x-axis. Basically, they're perfectly perpendicular, so we should expect to return a 1 there, because that is what the dot product returns there. Now, the cross product as well, as we looked into, is a bit more kind of like elaborate, and as you hopefully remember, this should return us back another vector. So as we talked about here now, these two vectors is basically going down in the z and in the x-axis. So hopefully now the cross product returns us the y-axis as well. So again, it works as expected, and to do the cross product we use the kind of hat symbol to do this. Another really nice thing here is that we can get the angle between vectors directly through the code as well. If we have two of these vectors, we can just basically say one vector dot angle and pass in another vector, and it will return the angle between those two vectors. Now, note that I've added in a bit more extra here, because let's just look at it. So we already talked about the vector, basically the vector and the other vector, right? Let's just refresh that real quick. They're going in Z and in X. Basically, we know that between those, we should be getting a 90-degree angle. Well, what happens if we just run this? It's giving us 1.5707. What is going on? Well, one really important thing to know about the mVector class, and with most of the transformation stuff that's happening in the API for Maya, is that it's dealing with it in radians. And radians is basically what it's kind of doing behind the hood, right? But it's not really easy for us to read or understand. We're used to degrees. So thankfully, we can use the math library to just change this for us. So if we run this whole thing now, boom, we get returned back 90, just as we expected. So that's just one thing to be aware of. If you're doing any kind of calculations and you end up getting really weird numbers that is around like 0, 0.5, like 1.5, and you are expecting it to be like, I don't know, like 40, 80, something, you're probably getting back things in radians instead of degrees. Okay, so we've looked a lot at how we're getting any of this information, but how about actually modifying the data that we have there? So I'm just going to scale this down a bit. So let's say that we take our original vector that we had, which is basically, right, remember it's going down in the, it's going forward in the z-axis, and we want to rotate that, right? So what we can do is we have the rotate by function, which basically allows us to rotate around, it allows us to rotate the vector around, right? Now, one thing to note about that is that this expects to get an M Euler rotation in. And this again is expecting to get radians and not degrees. If you just try to put in like, like an array here of like 90, 0, 0. Oop. Now, if you try to do that, it's not going to work, right? It says that a function takes exactly 2 arguments, just one given. So, what gives? Well, if we're doing this, it would potentially expect more things to happen here. Oh, now it's expecting a flow. Okay, so basically it's expecting an M Euler rotation to come in here. If it's not getting that, it's going to freak out a bit. So if we do that, we can basically first take any degrees that we want to rotate this about. So what I want to do here is I basically want to take this vector that I have going down in Z, and I want to rotate it around the x-axis, right? I basically want to, right, if I do that, I want to do this. So we should end up with a vector that's pointing up in y. And one thing to know, like I said, the M Euler rotation is expecting to get in radians. So what we first have to do is we have to make an M vector of radians, right? So again, we use the math library. We can just convert our degrees to radians. So we go from 90, we go back into like that 1.5707, and I'm just storing that here in its own variable just to make it a bit cleaner to see. So we're then passing that into the M Euler rotation, right? So you can see here, oh, sorry, I forgot to initialize those. So as soon as we have that, you can now see that we have an M Euler rotation with this, and we can now pass that in here. So if I do this, you can see that works now. And if I print this new vector, you can now see that I'm getting -1. And why is that? Because of course I was a bit of a goofus when I did this, and I'm rotating 90 positive around the x-axis. So you can see here, it's now exactly what we're expecting. That vector should be pointing -1 in y, and that's what it's doing. So what if we wanted to just rotate around a single axis? Well, you can do that like this as well. So instead of having to like create a whole M vector and doing this, if you just want to rotate around a single axis, you can easily do that by using the same rotate by, specifying an axis, and then giving it a radian value to rotate around that axis. So here you can say underneath the M vector class, there's a couple of extra functions, or sorry, kind of static values, where it's basically specifying the y-axis. We can also specify the x-axis and the z-axis, but for this case, we're going to be rotating around the y. So again, what we really have now is we have the vector pointing forward here, and we're going to rotate that 90 degrees around the y-axis. So we're basically going to be doing this, right? So we should expect this new vector here to return 1 in x. And you can see 1 in x, 0, 0. So that's exactly what we should be expecting there. So I hope that was a kind of, this is more to give you guys a bit of a reference on how to use a lot of the most common used functions in the M vector class. We're going to be going over how to actually use them and putting them into a bit more kind of practical use in the next video. Cool. Thanks, guys.